At the end of this session, you will be able to install 1 kilowatt solar panel mounting structure.
Tools and instruments or equipments. Pillar mounts. Quantity 2 numbers. Connecting frames quantity 2 numbers. Swinging rod quantity 2 numbers. Angle adjusting rods quantity 2 numbers. Panel fitting arms quantity 8 numbers. Toolkit, mounting screws, bolts and nuts, washers, anchor bolts. Tools, drilling machine, magnetic compass, marking pen and nail, thread, measuring tape, ruler, PPE kits. Install 1 kilowatt solar panel mounting structure. The roof suitable for installation of solar photovoltaic. The solar resource high enough. Installed capacity could fit on the roof. The energy could be 1 kilowatt solar photovoltaic system deliver. A rooftop solar photovoltaic installation comprises of photovoltaic panels assembled in arrays, mounting frames to support the panels and secure them to the roof, wiring, inverters and the other components depending on the types of installation. Marking base of pillar mount on rooftop. Follow carefully the steps for making foundation on rooftop where necessary PPE kits. Collect all elements of pillar mount on the rooftop. Collect all tools on the rooftop. Use compass and mark true north and south poles. Draw a line connecting north and south poles points. Connecting north and south marked points. Place the pillar mount aligned to the connecting lines. Mark the holes of base on ceiling. Draw a parallel lines in the direction of north-south at a distance as per the drawing. Place the second pillar. Mark the holes of second base on ceiling. Remove the pillar mounts. Verify the dimensions and parallelism before going to drilling on rooftop for pillar mount base. Drill holes on the marking for both pillar bases. Hammer the anchor bolts on the holes. Fixing the pillars on rooftop. Keep the pillar mount aligned to the anchor bolts and fix nuts. Mark parallel to the first pillar mount and repeat the above steps for second pillar. Fix the second parallel pillar and fasten the nuts. Check the parallelism between pillars. Assemble remaining components on the pillar mounts on rooftop. Finished pillar mount. Assemble swinging rods to the top of pillars. Assemble angle adjustment link rod between pillar and swinging rod. Assemble connecting frames between swing rods over the pillars. Leave the frames assembled to incline towards south. Do not tighten all the bolts. Additional mounting kits. Varieties of mounting systems are also in use so that based on type of roof, the type of system is selected. Rock mount, flush mount, roof mount, wall mount, pole mount, ground mount and ballast mount are common. Building integrated mounting are designed for green buildings. Set up solar panels 350 watts into 4 numbers on the mounting structure where the PPE kit necessary. Use the finished structure for pillar mount on rooftop. Assemble the panels over the frames with the panel facing south at desired angles. Check all fittings for correctness. Check the wind gap between solar panels. Secure tightness on base to roof and pillar to frame, bolts and nuts. Secure tightness on the panels to frame fitting points.
Recap. In this session, we have learnt how to install 1 kilowatt solar panel mounting structure. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session on Perform Cable Laying in the Field. At the end of this session, you will be able to perform laying cable in the field.
Tools and instruments or equipments required. Safety tools: helmet, safety shoes, hand gloves, insulated tools, safety belt, wooden ladder, safety spectacles, tool kit, mounting screws, bolts and nuts, washers, tools, drilling machine, marking pen and nail, measuring tape, conduit pipes, clamps and bends, etc. Suitable cables. DC or AC cables are types of cables used in installation. Cable structure will be bare copper, thinned as standards of IEC 60-228 Class 5. Double insulated cables. Cable sheet color: black, blue, red and green. These cables have properties like ozone resistance weather and UV resistance, flame resistance, resistance to acid and base. Nominal voltage for the cables: 600 watts or 1000 watts for AC and 1800 watts for DC conductors. Perform laying cables in the field. Most solar systems include basic cables, but sometimes we have to purchase the cables independently. The solar cable, sometimes known as photovoltaic wire or photovoltaic cable, is the most important cable of any photovoltaic solar system. The solar panels generate electricity which has to be transferred elsewhere. This is where solar cables come in. The biggest distinction in terms of size is between solar cable 4 mm and solar cable 6 mm. To understand how solar cables function, we must get into the core functionality of the cable, the wire. Even though people assumes cables and wires are the same things, these terms are completely different. Solar wires are single components known as conductors. Solar cables are group of wires or conductors that are assembled together. Perform laying cable in the field. An introduction to correct size and terminology. To start with, the most common size for solar wires is AWG or American wire gauge. If you have a low AWG, this means it covers a large cross-sectional area and hence has a lower voltage drops. The solar panel manufacturers supplies the chart that showcase connecting basic AC or DC circuits. They should give information on the maximum current allowed for the cross-section areas of the solar system. Wire gauge and amps rating. The size of solar panel cable used is important. The size of cable can affect the performance of the entire solar system. All electric wires functions in the same manner. If you have a photovoltaic cable that is not large enough to support the solar panel, photovoltaic cables are sized using American wire gauge in order to estimate the gauge scale. The standard wire gauge SWG series commonly used in Great Britain were given in BS 37371964. The standard is now withdrawn. The basis of the system is the mil or 0.001 inches. The lesser gauge number AWG of a wire, the lesser the resistance and the current flow from the solar panel will arrive safely. Different PV cables have a different gauge size. Each gauge size has its own AMP rating, which is the maximum amount of AMPS that can travel through the cable safely. Cable laying or conduit pipe wiring. Precautions while connecting cables, color codes, etc. If from rooftop, the wires coming out from the AGB are to be extended down the floors, conduit pipe wiring is preferred. Lay the conduit pipe on the wall for the required distance. Draw the wirings through conduit pipe using spring for entire length. Connect the end of wires to the solar photovoltaic input of solar inverter. DC disconnects are to be installed as per drawing. 250 WP solar panels are connected in parallel and develops the output voltage of 30 volts DC as sunlight fallen on them. This voltage is fed to the AGB through disconnector. The output of AGB given to the charge controller as input through disconnector. The output of charge controller voltage fed to the battery bank to charge the batteries. the battery voltage given as input of the inverter through disconnector. The inverter generates AC output of 230 volts AC, 50 Hz by taking DC voltage from battery bank. Practice cable laying by visiting ongoing mega projects by having MOU with solar photovoltaic integrators in plant training. Cable laid from solar photovoltaic array field to central inverter room. Cable precautions. Always wear protective clothing when handling cables. Connect with same color wires, red to red, black to black. Keep the cable connectors on the top place. Proper rating of cables must be used. Lay the cables through the conduit. Note: never disconnect photovoltaic module connectors or other associated photovoltaic wirings when they are energized.
Recap. In this session, we have learned how to perform laying cable in the field. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session on wire the above installation panels, battery, etc. to a 1 kilowatt solar PCU. At the end of this session, you will be able to perform wiring of components, interconnection in solar photovoltaic plant.
Tools and instruments or equipments required. Finished solar panel mount. Finished AJB wiring. Finished battery bank. PCU, power control unit or inverter. The interconnections given between components of solar photovoltaic system stepwise. With 6 solar panels are made 2 branches, each branch having 3 panels and are connected in series. At each branch, positive terminals are connected with red colored wires through MCB1 or DC disconnector, and negative terminals are connected with blue colored wires at AJB and input marked as plus and minus. The output from AJB wires are connected to charge controller as input through MCB2 or DC disconnector with proper colored wires and size. From charge controller, the output wires are fed to battery bank through MCB3 or DC disconnector. Battery bank output wires are connected through MCB4 to inverter input terminals. The inverter takes DC power and produce AC power and given to input of transformer through MCB5 or AC disconnector, and properly grounding or earthing also to be done. The output of transformer connected to distribution panel to AC loads through main AC disconnect. Perform wiring of components interconnection in solar photovoltaic plant. After completing fixing of mounting structures and fitting solar panels on mounts, then we have the activity of solar panel wiring. This involves connect the solar photovoltaic panels with the array junction box. Extend the wire or cable up to the inverter input in the process. The solar technicians have to perform assembly of connectors, wiring and extension till inverter input. The steps involved are identify the connectors, crumple the terminals and interconnect the panels, conduit pipe laying, lay underground cable, connect end terminals to inverter. Then interconnect solar photovoltaic panels and wire the array junction box. Finish the electrical wiring of 1 kilowatt solar photovoltaic off-grid plant. Wire the charge controller if separately available. Connect battery bank to charge controller or inverters. The case may be through DC disconnect. Color cables are used for easy understanding and to connect the units. Generally, black, blue, green and red color wires of colors used. Black and blue color cables are used for negative connections and red color wires are used for positive connections, and for earthing green color cables are used. Connect solar array output from combiner box through DC disconnect to charge controller. Connect charge controller output through DC disconnect to the input of the PCU or inverter. If charge controller is internal to the PCU or inverter, connect the battery terminals to corresponding input to the PCU or inverter. Do not switch on any disconnect or MCB. Verify all wiring are correctly done. Precautions. While testing, use hand gloves and safety shoes to avoid personal from electrical shock. See the all earthing points are given properly or not at the all equipments. Check all interconnections between battery bank, AJB, inverter and CC are given with different colored wires. While measuring the voltage at the different point, select proper range and mode of multimeter to avoid from damage. Record your observations and work done. Cautions are to be observed. Keep all the circuit breakers and switches in off position. Keep all fuses removed and stored separately till commissioning starts. DC volt more than 70 volts prove very dangerous. Once solar panels are exposed to sunlight, they start generating DC volt. Construction work continues for long period based on capacity of the plant.
Recap. In this session, we have learned how to perform wiring of components interconnection in solar photovoltaic plant. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session on Prepare a checklist for finding out errors during above installation. At the end of this session, you shall be able to get ready for first switch on.
Electrician toolkit and equipments required. Tools: hammer 1 kg, screwdriver set, crimping tool 3 mm to 16 mm, DE double-ended spanner set 6 mm to 15 mm, multimeter. Installed solar photovoltaic system. Get ready for first switch on. Check before first switch on. Safety precautions before initial starting. Check all the connections as per drawing. Make a separate checklist for possible errors during installation and check all points. Team leader should sign the checklist and is an important document. A list of checkpoints in the format of questionnaire to be separately by the team based on project also provided so that all the observations can be recorded and signed by the team to proceed further. Stepwise standard SOP points are given below. Check site survey and shadow analysis. Step 2. Installation of photovoltaic array mounting structure proper or not. Step 3. Installation and testing of structure earthing system. Step 4. Installation of photovoltaic modules with proper connections. Step 5. Check earthing of PV module frames. Step 6. DC cabling with standard colored wires. Step 7. AC cabling with standard colored wires and installation of inverter. Step 8. System protection and safety. Step 9. Placing of signage. Step 10. Pre-commissioning tests. Step 11. Commissioning the system. Get ready for first switch on. Evaluate the installation free of errors. Look out for possibilities of errors might have got included during the above phases. Group or blockwise. Testing and safety. Checklist parameter. Use proper safety procedures and equipments when working with electricity. Remarks. Yes. Verify that all disconnects are Locked in the open position with a warning label. S. Group or blockwise. Photovoltaic array. Checklist parameter. Make sure all modules are attached securely to their mounting brackets. Remarks. Yes. Visually inspect the array of cracked modules. Remarks. Yes. Group or blockwise. Wiring. Checklist parameter. Check exposed array wiring for correct rating and sunlight resistance insulation. Remarks. Yes. Check the all wiring and conduit are appropriately rated. Remarks. Yes. Group or blockwise. Charge controller. Checklist parameter. Check all the voltage settings correctly. Remarks. Yes. Verify that the charge controller operation. Remarks. Yes. Group or blockwise. Batteries. Checklist parameter. Coat each terminal with anti-corrosive gel. Remarks. Make sure that the location provides adequate natural ventilation. Remarks. Yes. Group or blockwise. Inverter. Checklist parameter. While disconnects are open, retorque all electrical terminal connections on the inverter. Remarks. Yes. Verify in the inverter manual that the array open circuit voltage under the record. Remarks. Yes. Group or blockwise. Grounding. Checklist parameter. Verify that only one connection in the DC circuits and one connection in the AC circuits is being used for system grounding. Remarks. S. Name of the company, address, plot number, street number, city, district, pin code. Inspector's name, signature. Team in charge name, signature. Get ready for first switch on. Model checklist. Solar electric photovoltaic system installation checklist. Following the completion of each item on the checklist below, check the box to the left of the item and insert the date and initials of the person completing the item, whether that is the installing contractor or owner installer. Remember to follow proper safety procedures while performing the system installation. The appropriate safety equipments for each section of the checklist is listed above each section of the checklist. Before starting any photovoltaic system testing, PPE, hard hat and eye protection. Check the non-current carrying metal parts are grounded properly, which are array frames, racks, metal boxes, etc. are connected to the grounding system. Ensure that all labels and safety signs specified in the plans are in place. Verify that all disconnect switches from the main AC disconnect all the way through to the combiner fuse switches are in the open position and tag each box with a warning sign to signify that work on the photovoltaic system is in progress. Photovoltaic array circuit wiring, PPE, hard hat and eye protection. Check home run wires from the photovoltaic modules to combiner box. At the DC string combiner box to ensure there is no voltage on them. Recheck that fuses are removed and all switches are open.
Recap. In this session, we have learnt how to get ready for first switch on. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session on Perform Overload Test and record observation. At the end of this session, you will be able to carry out overload test.
Electrician toolkit and equipments required. Tools: hammer 1 kg, screwdriver set, crimping tool 3 mm to 16 mm, DE double-ended spanner set 6 mm to 15 mm, multimeter, documents and test equipment. Carry out overload test. Conduct overload test and explain to the customer. After assuring the above steps is free of any defect, connect the load step by step. Check for overload indication. Connect little excess load and observe. Overload test. Short circuit indication. Use ELCB. Visual and audio alarms. Tripping of circuit and breakers. Protection circuits operation. Record all the above in printed forms. This is an important document for the customer as well as for solar company to claim against any warranty and guarantee. First inspection report generation. Carry out overload test. Customer orientation. Advice for regular checkup of panels, inverter and battery. Not to make any alteration to any component. Not to use acid mixed distilled water for batteries. Not to clean the terminals of the battery. Not to pour water in nearby area to inverter. Not to open the inverter at any cost. In case of risky observation, let them shut down the unit and inform maintenance team. Switching loads. Economical planning of load distribution can be taught to the customers for efficient and optimum utilization of the plant. This can bring enough return on investment. Observation of parameters pre-operation and operational test before connecting to load. Switch on disconnect of charge controller to battery. Switch on the disconnect of battery to inverter. Switch on disconnect of solar photovoltaic panel to charge controller. Switch on the inverter. Observe correct working condition of above before connecting load. Test and measure voltage and current on. Battery voltage. Charge controller. Solar panel. Inverter output. Observation of parameters post operation. After assuring above step is free of any defect, connect the load step by step. Check for normal load operation, progressive load connecting and on load testing. Overload indication. Connect little excess load and observe. Overload testing. Short circuit indication. Use ELCB. Visual and audio alarms. Tripping of circuit and breakers. Protection circuits operation.
Recap. In this session, we have learned how to carry out overload test. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session on Prepare a first inspection report on the solar plant installation. At the end of this session, you will be able to organize first inspection report.
Tools and instruments or equipments required. Multimeter, line tester, insulated screwdriver, documents and test equipment. Organize first inspection report. Generate a first inspection report of a solar photovoltaic plant while handing over the plant. Perform the first switch on activity after the satisfactory visual inspection of installation. Verify AC mains input voltage and current, solar array voltage and current, battery charging voltage and current, inverter output AC voltage and current in the prescribed form brought from company. Perform the above step with no load step-by-step increase in load, full load and little overload condition. Record all the actual observations in front of customer to show him the proper functioning of the solar photovoltaic plant what he ordered. Record any abnormality noticed and rectify it if possible. Inform maintenance team otherwise. Take the acceptance from customer by getting his or her signature in the test report. Recap.
In this session, we have learnt how to organize first inspection report. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session on prepare a list of do's and don'ts in the installation. At the end of this session, you will be able to formulate do's and don'ts.
Tools and instruments or equipments required: multimeter, line tester, insulated screwdriver, documents and test equipments. Formulate do's and don'ts. At different stages, the list of do's and don'ts. Solar modules, AJB array junction box, CC charging controller, inverter or PCU power control unit, battery bank. Organize a list of safe handling of the solar photovoltaic plant. Solar modules. Do's. Clean the glass surface of the module using water and a soft sponge or a cloth every 15 days. Check the electrical and mechanical connections periodically to verify that they are clean, secure and undamaged. Check for corrosion. Check front of modules for cracking, cut or other damage to glass. Check modules for evidence of burning under glass. Don't. Do not use any detergent. Do not attempt to disassemble the module connection. Do not remove any attached nameplates or components. Do not apply paints or adhesive to the module. Do not use mirror or other hardware to artificially concentrate sunlight on the module. Do not stand or step on module. Do not place any heavy objects on the module. Avoid shadows falling on panels. Do not displace the panels from the mounting structure. Prepare a procedure for cleaning the photovoltaic modules, including period of maintenance. The normal operation of the photovoltaic system is automatic band, does not require any intervention by the customer. However, he should know about the basic procedures to clean the photovoltaic module for a good performance of the system. Give information on possible significant variation in the system performance under varying conditions such as rain, fog and sunshine. Give information on electric shock possible areas. Include managing batteries and maintenance of batteries. Educate about saving energy. Give methods of load management. Explain method of cleaning the area around inverter frequently. Include method of changing fuse. Explain what are possible by the customer. Clearly explain what conditions need the customer to call the maintenance team. AJB array junction box. Do's. Get the PCU installed by a qualified installer in accordance with the installation instructions provided in this manual. Plan and segregate the load and associated wiring on the site. To connect to the PCU, more than 2 sources may energize PCU before servicing or maintenance. Make sure that all the sources are de-energized. Use proper lockout or tag-out procedures. Use the same make and model of solar photovoltaic modules. Mixing different panels will result in decreased performance and possible failure. Use the same make of model of batteries, same age, amp hours rating, voltage and brand of battery bank. Tighten all the mounting anchor screws properly. Check the tightness of all electrical connection screws every 6 months. Use standard insulated wires for correct size and type of wiring. Follow local wiring code. Energize the source after completing and checking all the connections and wiring. Provide mechanical stress relief to cables coupled to electrical terminal. Do regular maintenance of the PCU. Check ventilation and integrity of wire termination on connectors by a qualified service personnel. Check the PCU for proper grounding. Ensure to comply with local requirements and regulation. Understand the operating modes and settings as per your requirements and customize the settings. Review and ensure the operating mode and settings for optimum operation per your requirements. Do not use the equipment if physically damaged. Do not cover or block ventilation openings in PCU. Do not install the PCU outdoor, prone to exposed to direct sunlight, dust, insects, rain and moisture. Do not recharge a frozen battery. Do not tamper vent plugs of the battery. Do not deep discharge the battery below specified limits. Do not allow tapping in between batteries during the service life. Do not work in vicinity of lead acid batteries. Batteries can generate hazardous gases during normal operation. Do not change the battery type of battery from flooded to another type without changing the settings in PCU. Do not install and or operate in compartments containing flammable materials or in locations that requires ignition protected equipment. Do not use the PCU in connection with life support system and medical equipment. CC Charging Controller. DOS Automatic Identification System Voltage 12 volt 24 volt auto recognition. Humanized LCD displaying and double button operation of man-machine interface. Completed technical data for setup and modify. High efficiency intelligent PWM 3-stage charging. The load control mode can be selected. The timer function can be reset for street light at night. Reliable over voltage protection, short circuit protection, overload protection, overcharge protection, over discharge protection, accurate temperature compensation, correcting the charging and discharging voltage automatically, improving the battery lifetime, roundly reserve connected protection, solar panels, battery, solar charge controller. Positive poles are all connected together, adopting negative MOSFETs in series control circuit. It is better to install the controller in the room. Don'ts. If install the controller outside, please keep the environment dry. Avoid direct sunlight. The controller will be hot in process of working. Please keep the environment ventilation away from flammable materials. The open circuit voltage of solar panel is too high, especially 24 volt system. Please take care. The battery has acidic electrolysis. Please put on goggles during installation. If you accidentally exposed to electrolysis, please rinse with water. The battery has huge power. Prohibit any conductor short circuit the positive and negative pole of battery. Suggest to adding a fuse between battery and controller. Slow motion type, the action current of the fuse should be 1.5 times rated current of controller. Inverter or PCU power control unit. Do's. Keep the room properly ventilated. Check functionality by display and indications weekly. Clean the inverter surface weekly. Check all the connections are properly tight end. Don'ts. Do not remove any attached nameplates or components. Do not open the PCU cover to clean or for any other purpose. Do not Change electrical connections on your own. Do not allow water to drip or splash on the PCU. Battery bank. The ambience. Makes sure that the surrounding is moisture free. Makes sure that the battery room is properly ventilated and clean. Do's. Weekly basis. Clean the top surface and terminals of the battery once a week. Do's. During battery servicing periods, check the distilled water level once in 4 months and if required, refill as per the guidelines. Battery shouldn't be overfilled. The maximum electrolyte level is approximately 1/4 to half below the vent well tube which extended down into the battery. Check for distilled water leaks due to the cracks or overflow. Check for corrosion at terminals and connections. Check the battery terminal safety caps is mounted properly. Clean your hands thoroughly after every time you handle the battery. If required, apply petroleum jelly to the terminals. Do not touch both battery terminals with your bare hands at the same time. Remove watches and jewelry when working with or near battery to avoid shock. Never keep tools or other metal items above and near a battery. Do not smoke in battery charging areas as the acid used in battery is inflammable. Prevent open flames and sparks in battery charging areas. Do not allow anybody except SELCO representatives to change any of its parts.
Recap. In this session, we have learnt how to formulate do's and don'ts. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session on Demonstrate Standard Operating Procedure of Photovoltaic System. At the end of this session, you will be able to follow SOP of Solar Photovoltaic Electrical System. Demonstrate various safety measures to be taken in the field or site. Monitor activities and foresee problems. Solve issues on site. Execute remedial actions at once. Adapt the standard operating procedure on solar photovoltaic installation site.
Tools and instruments or equipments required. Personal protect equipments, fall protection equipment, documents and test equipment. Follow SOP of solar photovoltaic electrical system. Collect information on probability activities by solar technician which may result in injury or accident to one or more persons in the team. Divide the technicians into groups of 4 or 5 each. Select workplaces different for each team. Visit the spot on different days and time. Collect details of occurrences all over which may lead to injuries, failures, health issues or accidents or any other kind. Specify. Classify the events based on men, machine and material. Evaluate the happenings based on risk, waste, fire and emergency, electrical, work at high and fall, tools and equipment, traffic, men or material, personal protection, fellow workers, on-site people protection, work permit, lifting or handling, health, safety, highlight chances of failures to men or material or anything else. Specify. Suggest precautionary measures. Suggest actions of remedies in case of failure. Suggest educative aids to improve safety. Prepare a SOP in general. Note. Work spot where installation is going on. Finished and operating photovoltaic plants. Plants under AMC. Plants not under AMC. Any other photovoltaic site selected by the instructor. Define nature of site. Demonstrate various safety measures to be taken in the field or site. Preparation of safe work area. Arrange materials and tools for safe working. Study the list of materials, tools and equipment. Compare with site requirement and add or delete any item required or not required. Recall the usage of tools and equipment. Learn and practice about unknown or forgotten means. Educate the team members about everything in the list. Demonstrate once using of PP kits and explain what happens when not used. Prepare short guidelines after these exercises for safe working in the site as a reminder. Monitor activities and foresee problems. Assess to implement safety policies and procedures. Practice implementing. Define hygiene. Define first aid. Practice safety policies. Report abnormalities with reference to the safety policies to your supervisor or team leader. Display the basic identity of hazardous products. Affix material safety data sheets at workplace if not provided even after reminding. Implement for housekeeping policy of tools and equipment, components and protective equipment. Adopt strictly safe working at heights policy. A worker must wear a safety belt of safety harness with a lanyard tie off to a fixed support whenever the worker may fall 3 meters or more. Display a statement of purpose of the policy. Display an expression of the organization's commitment to controlling the hazards or issues at its source. Display an outline of how the hazards or issues will be controlled, including resources to be provided and a time frame for action. The roles and accountabilities of relevant stakeholders, particularly managers and supervisors. Affix a description of how the safety policy will be implemented. Safety policy format. Practice safety procedures. Help to demonstrate and display a written statement of health and safety policy. Assess to implement the overall workflow from materials coming into the workplace to the final product going out. Inspect workplace safety. Display the step-by-step activity procedure where there are workplace hazards and risks to the health and safety. Identify workplace hazards and issues. Hazards identification, risk assessment and risk control safety procedure. Collect information about the hazards activity or issues. Prepare the policy or procedure. Implement the policy or procedure. Report hazards. Help to investigate incidents and issues with corrective actions. Support reactive and response activities such as first aid and medical emergencies. Report illness, injury. Report incidents and dangerous occurrences. Help to establish the first aid procedure. Solve issues on site. Risk management, waste management, fire and emergency procedures, electrical safety, work at height and fall prevention, tools and equipment, traffic safety, personal protective equipment, work permit system, safe lifting operations, health and safety audit procedure. Execute remedial actions at once. Working surface conditions, oil, grease, wax, fluids, ice, irregular surfaces. Working at heights with portable ladders, fixed ladders, elevated platforms, scaffolds, cherry pickers, catwalks and other evaluating devices. Factors for increased potential for electrical shock, tripping, slipping and falling are highlighted below. The surface of photovoltaic modules is normally slippery. When installed on a peaked structure or when the modules are wet, they become extremely slippery. Do not walk on modules. Accidental contact with high voltage photovoltaic components could cause involuntary muscle reaction and could result in a fall from the structure. Firefighters should never attempt to place a ladder on photovoltaic modules. Do not attempt to break the glass covering photovoltaic modules as this could expose high voltage initial components within the module and increase the risk of electrical shock. The mounting racks, electrical conduit, and wires are sometimes partially concealed and are not always visible during the day. They become even more difficult to identify in the dark or in the presence of smoke. Adopt the standard operating procedures on solar photovoltaic installation site. Practice safety procedures. Help to demonstrate and display a written statement of health and safety policy. Assess to implement the overall workflow from materials coming into the workplace to the final product going out. Inspect workplace safety. Display the step-by-step activity procedure where there are workplace hazards and risks to health and safety. Identify workplace hazards and issues. Hazard identification, risk assessment and risk control safety procedure. Collect information about the hazards, activity or issues. Prepare the policy or procedure. Implement the policy or procedure. Report hazards. Help to investigate incidents and issues with corrective actions. Support reactive and response activities such as first aid and medical emergencies. Report illness, injury. Report incidents and dangerous occurrences. Help to establish the first aid procedure. Recap.
In this session, we have learned how to follow SOP of solar photovoltaic electrical system, how to demonstrate various safety measures to be taken in the field or site, how to monitor activities and foresee problems, how to solve issues on site, how to execute remedial actions at once, how to adapt the standard operating procedures on solar photovoltaic installation site. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session on demonstration of solar panel maintenance, cleaning, DC array inspection, precaution while cleaning. At the end of this exercise, you shall be able to perform maintenance of solar photovoltaic panels.
Tools and instruments or equipment required. Container, clean water, wiper, cleaning fluid. Perform maintenance of solar photovoltaic panels. Clean the solar photovoltaic array. Manual. Do not sit, stand or walk on solar panel. Even keeping palm on panel for resting for few moments also can damage internally the photovoltaic cell. Ensure water used is free from dirt and physical contaminants. Deionized water is preferable. Water with mineral content more than 200 ppm should not be used. Cleaning agent must be mild. Non-caustic and non-abrasive detergents may be used. For normal cleaning, where dirt is not visible, only water or thinly diluted cleaning agent can be used. Add more cleaning agent where dirt or dust level is more. Pour the mix on the surface exposed to sun and gently brush with wiper to clean. Do not brush or clean on the reverse side of the modules to avoid damage to the lead wires or the junction box. For removing stubborn marks of bird droppings, insects, dirt, etc., make use of soft sponge, fiber cloth or non-abrasive brush. Do not sit, stand or step on the modules for cleaning. Do not use a metal brush to clean solar panel surface. DC array inspection. DC array inspection will give details on module condition, module cleaning, damage of module, dirt accumulation, etc. Inspect a subset of array top glass inspection. Backsheet inspection. Look for spots, blisters burned through, discoloration. Proper wire condition and sizing. Check for connectors on array wiring extensions. Inspect module and array junction boxes. Look for sealants, proper wire management. Inspect module clamping methodology. Check for loose fasteners, secured and sealed properly. Inspect array for buildup of debris underneath. Clean whenever necessary. Visually check array. If broken, damaged or loose module, loose rocking hardware, wiring and MC4 connectors. Visually check all DC disconnections and combiner corrosion, blown fuses, moisture entry, heat distortion, insect or rodent issues. Check for ground continuity between the frames and rocking structure. Check for continuity of cable to electrical earth. Recap.
In this session, we have learnt how to perform maintenance of solar photovoltaic panels. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you. A warm welcome to this session on inspection of mounting structure of solar modules, procedure of replacement of defective fixtures. At the end of this session, you shall be able to collect evidences for failure of mounting possibilities in existing solar photovoltaic plant, repair the defective fixtures on module mounting structure.
Tools and instruments or equipments required. Visit to existing solar photovoltaic plant. Solar array logs sheet. Layout of solar photovoltaic array in a solar photovoltaic plant. Details of fixtures or MMS installed including dimensions and material. Method of installation guidelines. Spare parts. PPE kit. Material handling equipment. Multimeter. Thermal camera. Cartridge fuses. Spare. DE. Double-ended spanner set 6 mm to 15 mm. Crimping tool 3 mm to 16 mm. Measuring tape. Spare wires and cables. Collect evidence for failure of mount possibilities in existing solar photovoltaic plant. Factors influencing the failures and against which PM activities is carried out are vibration and noise, shock, dust, damage of cover, stains and smudges, temperature, humidity, corrosion. Continuous monitoring, cleaning and inspection helps in getting alert about the problems leading to failure. A minor failure ignored or not noticed at the beginning leads to permanent breakdown later. Hence, perfect monitoring of failure chances and preventing measures taken in time avoid all breakdowns. The main activities under PM of solar photovoltaic system include mounting structure integrity, module cleaning, hot spots detection, junction box servicing, inverter servicing, cabling connections, balance of plant, earthing protection, vegetation control. Repair the defective fixtures on module mounting structure. MMS means module mounting structure. Owing to the structure of the modules themselves, they are required to be mounted on another structure. This allows the modules to be held firmly to the surface of installation, capable of battling strong winds. Additionally, in order to raise the overall efficiency and generation capabilities of the installation, a tilt is offered to the modules of the system base on the geographical location and the positioning of the area of the installation. Flat concrete roof. For a flat concrete roof, an MMS is of immense importance as it is the MMS that allows the modules to be tilted at an angle optimal to the particular installation. Cleaning of battery terminal corrective maintenance. Replace as and when failed. Most preferred for electronic control systems, because failures of components are random and cannot be predicted. Carrying out preventive maintenance action itself may be a real cause of the fault. Corrective maintenance is concerned with the detection, location and repair of the faults as they occur. Developing skills in this area requires good understanding of overall system, its circuit operation and its fault location methods. Repair the defective fixtures on module mounting structure, tightening loose connections, replacing damaged modules, replacing blown fuse, repairing blown fuse, rectifying inverter faults, repairing equipment damaged by intruders, replacing blown connectors, rectifying SCADA faults, rectifying mounting structure faults. Log sheet for maintenance. Recap.
In this session, we have learnt how to collect evidences for failure of mount possibilities in existing solar photovoltaic plant, how to repair the defective fixtures on module mounting structure. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you.
Today I will be discussing about guidelines for E&M planning and execution. First of all, I will be discussing general points of planning. Some of the mistakes observed during scrutiny of AEs are as under. The basic input data of electric and water